So here is a simple Arduino Uno R4 board where we are interfacing it to a DHT11 sensor. So this is a PCB type DHT11 sensor where you can see the sensor is mounted on a PCB. Okay, so for this particular sensor, the pull-up on data pin will be on this PCB, so you need not connect an external pull-up here. And this particular sensor DHT11, as per specs, it works between 3.3 to 5.5 volt. So we connected a 3.3 volt, the red wire here from Arduino Uno R4 to VCC, and then the ground pin is connected. So ground is necessary, right? And the data pin, the D8 of the Arduino Uno IDE is connected to the data pin. So this particular sensor outputs data every 2 seconds. Okay, so that's what we have to read, and the aim is to print the data on the serial monitor of the um, Arduino IDE. Okay, let's look at how the code is. So this is the code for the DST11 sensor read. So here we have defined the pin 8, which is nothing but the D8 pin of the Arduino connector on the Arduino Uno R4 board, and the sensor type is declared as DHT11. So we have a inbuilt library. So if you don't have a library installed, go to the library manager here as we clicked and search for DHT11. Okay, as you search for DHT11, there will be several options that will be coming up. You can install any of this. So we have used a DHT sensor library by Adafruit. You can see here that this is installed. In case if this is not installed, you will get a compilation error. So install this, and then we are creating an object, okay, of DHT. Okay, so this actually there is a class that is defined inside the library, and we are trying to create an object for the same here. Okay, so you need to go through the library to understand what is happening, and then you can understand why we have created an object here. So for now, to use that particular function, we are creating a an object here. Okay, and you can see here in the setup function we are creating a serial port which has a baud rate of 9600, and every time we are trying to, once it comes to the setup, we are saying DHT11 sensor reading on Arduino Uno R4. Okay, and then it goes to the begin. Begin means the sensor starts functional. Okay, the main point about this particular sensor is this particular sensor sends out data every 2 seconds. Okay, so if we go back to the diagram which we mentioned, where the PCB is there on which the blue sensor is there. Inside that, there is a temperature sensor, there is a humidity sensor, which are actually connected to a onboard ASIC. Okay, so that particular ASIC actually reads the analog data and gives out the data on the data pin. Okay, so that gives out every 2 seconds. So that's why there is a delay of 2 seconds here. And then we are trying to read the temperature, humidity, humid temperature in both Celsius and Fahrenheit. So using read humidity, read temperature. Okay. So this generally in coding, it is important that we handle the error conditions. So if at all there is a issue with the sensor, or we don't get readings from the sensor, or there is some problem with any of these functions used, and we get some junk value into this HTF variables, there is every chance that you might print a junk value on the serial port, right? So to avoid that, in case any of these reads fail, we are using is not a number function here. Okay, and passing this variable, and is not a sensor, not a number function, returns high. That means this is not a valid value H or T or F. In that case, we print failed to read from DHT11 sensor. Okay, in case if everything is fine, what we are doing is we are trying to print the H and the T and the F. Okay, temperature in degrees centigrade and Fahrenheit. All others are just texts here. Okay, and this is tab that we are printing. Okay, and that's it. So very simple, right? If you are using an inbuilt library, it's very simple to use this. Now, okay, let us try to run this, compile and dump this. Okay, and once this is done, okay, so we are done with the compilation. Once this is done, the code will be running on the board and it will be outputting the data if everything is fine. So go to the tools, serial monitor, and you can see here it is printing the temperature and the humidity. Now we'll try to change the values here. If you blow around the sensor, you can see the temperature got changed and humidity also got changed. Okay, so you can experiment in your own way, keeping at different places and reading these temperature, humidity values. Okay, right now we are doing this in Hyderabad, and you can see on a rainy day, like in a rainy season, without any rain, we see humid conditions with a temperature of around 28 degrees. So this gives a clear indication, and we can say a simple IoT application, right? If you are a beginner, a very simple IoT application which actually gives out the value. So the main important point to note here is you don't even have to know the inbuilt functions. You just need to use the APIs there, call those in the sense call those functions and use them in your code and print whatever that particular function is giving back. Okay, all these functions are interacting over the uh, data pin with the temperature and reading the data, and it is printing out. So for a beginner it is very important to understand what is happening, and especially if you want to write a code, a full length code of this particular sensor, it's very difficult and it takes sometimes weeks to complete. There'll be timing issues, there'll be errors in the code. So ultimately, if you are a beginner, it is good that you use the inbuilt functions, use them, and also what happens is not only ease of use, right? It also becomes easy for you to debug the code, and ultimately, all these libraries are approved and used by various engineers worldwide, and you need not have any issues. In case if you have any issues, you can post in various forums, and you get a lot of data. Only thing, see here that once the library is installed, as we mentioned, you need to include dht.h. This header file must be enough to give you access to all the functions and the classes inside the libraries which are a part of that DHT11 sensor library. Okay, so the usage of sensor has become very very easy, right? What you can do further is you can analyze this data, write your own conditions, add according to the conditions or whatever you want. You can add wireless functionalities. So ultimately it's more of the application code that you are trying to write, rather than focusing on developing a driver for this. Hope we gave a glimpse of what is happening here with the DST11 and Arduino Uno 4. Please post if you have any questions. Thank you.